Hello guys, welcome to ASPE Respiratory System, Anatomy and Physiology. So this is your last lesson of the year on anatomy and physiology. It's massively important that this goes in because I think, respiratory adaptations are the only set of adaptations that have not come up in a discrete question, like a 1 to 6 mark question. And secondly, it's also one of our preparation 10-mark question topics. So really important we get this in. So just quickly looking at the big picture then, you've got respiratory system in the middle. We'll have a quick recap of the oxyhemoglobin dissociation curve, and we'll also have a look at a recap on altitude, okay, just to make sure that that has gone in, because remember these two are massively linked, okay. Then we're going to have a look, the key focus of the lesson is first of all we're going to look at the adaptations that take place to the respiratory structures as a result of taking part in a prolonged period of aerobic exercise, like a 6-week training program. Then we're going to have a look at kind of the effect of asthma and how that dictates or how that links to the respiratory system. And finally, we're going to have a look at smoking and have a look at how that links to one, respiratory health, e.g. kind of the structures within the respiratory system. Secondly, we've also already had a look at the effect of smoking. Okay, remember we changed the S to C, so carbon monoxide released, reducing the association between oxygen, hemoglobin, etc., and how that affects performance. So if we go from here then, going on just quickly then, the adaptations to the respiratory system fall under kind of certain categories. Firstly, we're looking at kind of gaseous exchange. So we've talked about gaseous exchange, we talked about alveoli, we talked about the muscle tissue gaseous exchange. That's going to be our first focus, and how a prolonged period of exercise changes those kind of structures for the better in terms of oxygen and carbon dioxide diffusion. Following that, we're going to have a look at how the mechanics of breathing. Remember, mechanics of breathing refers to Dr. VP. So we're talking about diaphragm plus muscles. Then we're talking about ribs, thoracic cavity volume, thoracic cavity pressure, and then where the air goes. We're looking at how those things, those key mechanics, how the Dr. VP changes in terms of how it can take more air in and exhale more breath. So going from there, final thing, respiratory volumes. There are 3 volumes we have to know about in terms of what they are and how they increase as a result of long-term training. So that's kind of how we're going to look at it. I will go through these now. All I need from you is call down notes on 1, 2, 3, 4, 5 adaptations to respiratory training, and then I also need a little bit of information on what asthma is, the causes of it, the symptoms and how you prevent it, then a little bit on smoking and the effect on the respiratory health. Okay, so yes, it is a long screencast, it's really worth it because within the lesson I'll give you direct memory methods on how to remember this, and they will be easy. Absolutely easy as long as you take the time to do these notes. Some of your notes today were appalling. I saw people writing questions when they came into the lesson. It's not acceptable. Again, it's close to the end of the term. You cannot afford to have a lesson that's bad. Okay, right, moving on then. So first one, key introduction. So basically aerobic training, anything where you're kind of utilizing oxygen for a prolonged period of time, anything over about 3 to 4 weeks will lead to kind of an increased ability to take in oxygen and supply it to the working muscles. So the reasons why we have an increased efficiency to take in oxygen supplied to working muscles are because of 4 or 5 key adaptations. Now, the first adaptation that takes place is as follows, and it takes place to the alveoli. So what happens is aerobic exercise or prolonged periods, say for example 60 to 80% of your maximum heart rate, jogging 3 to 5 times a week, this will lead to an increased surface area of the alveoli. Now we know alveoli is the primary kind of site for gaseous exchange, so if that gets bigger, it means we've got a greater site for diffusion of oxygen when we initially breathe it in, and then we can move it into the kind of blood in order to bind with hemoglobin to form oxyhemoglobin. So all you need to know is, okay, in your first call out note, the first adaptation, increased surface area of alveoli. This leads to a greater site for diffusion of gases. Okay, that's your first thing. Question needs to be linked to that description. Next one. Okay, the next thing that happens is capillarization. Now, capillaries are blood cells, okay, that help in the process of gaseous exchange. And what happens is there's an increased density of capillaries around 2 sites. Now, we know there's 2 sites in which we're concerned with for gaseous exchange. Site 1 is the alveoli. So we just talked about the alveoli increasing in surface area, but not only does the alveoli increase in size and surface area, it also has more capillaries located around it. So because of that, it gives a greater kind of, pathway for gaseous exchange, because not only is the site increased, but also the blood cells which carry the oxygen is going to increase as well. So basically, what does that mean? If we have more capillaries around the alveoli, it means that we can have more oxygen diffused into the blood, and then alternatively we can diffuse more carbon dioxide to the alveoli from the blood. Okay, so because of these, we know those terms because the diffusion gradient is created during exercise. So basically, all of this will lead to an increased efficiency of gaseous exchange. If you want the posh term or the technical term, this is known as pulmonary diffusion, because anything to do with the lungs can be translated to pulmonary. So I certainly expect you to be putting that if you get a 10-mark question. Now the second thing, so adaptation 3, it's still capillarization, but capillarization also takes place around the muscle tissue. So capillarization of the muscle tissue, so once we've got that kind of oxygen diffused from the alveoli, capillaries diffuse it into the blood is hemoglobin, oxygen binds to hemoglobin to form oxyhemoglobin, and it's carried. Okay, so now what we need, in order to make sure that we have a more efficient diffusion of oxygen from hemoglobin into the muscle cell, we need capillaries around, or more density of capillaries around the muscle tissue. So basically what happens is exactly that. There's an increased capillary density around the muscle tissue, which allows a greater amount of oxygen to be dissociated or diffused from hemoglobin into the muscle, and alternatively we have an increased ability to diffuse carbon dioxide from the muscle tissue into hemoglobin to form carbomonohemoglobin and take it and get rid of it via the alveoli and breathing it out. So basically that could be summed up as an increased efficiency of gaseous exchange at the muscle tissue, okay, or muscle tissue diffusion. Going on then. Next one, the mechanics of breathing are also directly affected by aerobic training. Now, if I said to you now, you are very aware, you don't go do a period of exercise and then have bigger ribs. You're not going to get thicker ribs. What you are going to get is the muscles that are attached to the ribs, or kind of helping that concept of kind of breathing in and out, are going to hypertrophy. So if you was going to sum that up, it's called respiratory muscle hypertrophy. So the key adaptation is increased efficiency of mechanics of breathing. Aerobic exercise will improve the efficiency and mechanics of breathing due to respiratory muscle hypertrophy. The muscles that hypertrophy are the two key muscles that we always talk about. So the D for the doctor. So you've got D, diaphragm, and then you attach that to the intercostal muscles. Both of those increase in size and strength. And then you have further muscles. Now I feel like you need to have one inspiration-based additional muscle and one expiration-based additional muscle. So the first one you've got there is the scalenes, that helps inspire more. You could also have the sternocleidomastoid if you want to put that in. It certainly looked good in a 10-mark question. And then you also have an increased hypertrophy of the abdominal muscles, which allows you to breathe out better. Now the net effect of these kind of muscular adaptations of the respiratory system is that you have an increased ability to breathe deeply in, so increased depth of breathing due to inspiration. So you've got those kind of things like scalenes and sternocleidomastoid allow more air in, increased depth of breathing, and you also have an increased rate of breathing as a result of kind of things like the abdominals or the external obliques, which allow you to breathe out more. Okay, so that is kind of where you finish on mechanics of breathing. Okay, then we go on to lung volumes. So I've said to you on lung volumes, what's the key thing here? How does aerobic exercise improve lung volumes? Okay, so basically the key volume I'm concerned with, and this will act as a trigger tomorrow for our memory hooks, is going to be increased tidal volume. A tidal volume is very similar to stroke volume, but don't get it mixed up, because we're talking about tidal volume, we're talking about air. So it's a volume of air moved in and out of the lungs during one breath. Okay, that will increase. So you can take in and take and expire more out in one breath. Now this happens during maximum exercise. Secondly, you increase your minute ventilation, which would be the equivalent of cardiac output during cardiovascular adaptation. So you increase the volume of air you can take in or inspire and expire in 1 minute during maximum exercise. The final thing you can increase is vital capacity. Now, I mean, you don't have to define all these. You can just put the words if you want. Vital capacity is a maximum force that you can exhale breath out in one breath. So you can imagine that it's a peak flow. So basically when you're being tested for asthma and you have the peak flow machine, it's the maximum amount you can force out or blow into the tube. Moving on then. Okay, there's a net effect of these adaptations. So what is the kind of key terminology the examiner is going to be looking at? Yes, you can recall. I will give you a way to remember all of those. So it'll be the numbers. We'll have 9, 1, 3, 5, and we'll look at word associations for those. And then that will directly increase VO2 max, which is the amount of air you can take in and utilize during exhaustive exercise or maximal exercise. And also it delays something called OBLA. Now OBLA is the onset of blood lactate accumulation. And if you exercise for long periods periods of time and have cardiorespiratory adaptations, it means the point at which you feel the burning sensation of lactic acid in your legs is pushed back to a higher percentage of your VO2 max. So basically, I mean, elite athletes will basically only experience obla at 90% of their VO2 max, whereas kind of untrained athletes can get it as low as 30, 40, 50% of their VO2 max, which is the maximum amount of air you can take in and use during exhaustive work. So you just need to know those two key terms. That is how it affects your performance as a result of respiration and the adaptations that take place. Now, asthma, if I could just get you to make brief notes. What is asthma? It's a reversible narrowing of respiratory airways. Example of a respiratory airway is a bronchioles, okay, and that leads to something called bronchitis. And if you can imagine, if you've got a narrower bronchi, e.g. one of the key tubes in which you're trying to inhale air, it means that you'll have less oxygen in the alveoli. That means there's less oxygen diffused into the blood and therefore muscles. Now, the key triggers to people getting asthma are things like pollen. You can have exercise-induced asthma, so winter sports such as skiing are really susceptible to it due to the cold, dry nature of the air. Now, from there, the next bit you're looking at, the physiological effects of having asthma then. So obviously what we have is, firstly, aerobic performance is decreased because we can't get as much oxygen. So this will lead to the kind of underpinning features of that is a decreased tidal volume. Okay, there's a reduced efficiency of gaseous exchange at the alveoli and the muscle tissue because we can't diffuse. We haven't got enough oxygen. It's a bit like altitude. We haven't got enough oxygen in the first place. So the whole process of breathing in and out is decreased, tidal volume. The whole process of oxyhemoglobin dissociation is reduced. Alveoli diffusion is decreased. There are certain methods you can use for controlling asthma. An inhaler, a 10 to 30 minute warm up can help get that oxygen in and diffuse, and you can also do something called inspiratory muscle training, okay, which is basically really focus on that diaphragm intercostal muscles and trying to train those. Now the last thing, smoking. Smoking has certain health effects, so basically it decreases the elasticity of respiratory structures, okay, so basically you'll have things like alveoli going to become more rigid, okay. You also have a narrowing or constriction of airways or respiratory pathways, so the bronchi, the bronchioles. So you've basically got certain things. So what do we get? What diseases come as a result of different parts of the respiratory system being kind of hampered by smoking? Firstly, the alveoli. So basically, if the alveoli are damaged, this can lead to emphysema, which is kind of cancer, and then you can also have, we'll leave it there. That'll do. Okay, so can you make notes on those? I need from you 5 adaptations. Okay, you need to say what they are, and then you need the net effects of those 5 adaptations on the respiratory system. Following that, can you just give me a little bit of information on asthma? Describe it, the reversible narrowing of respiratory airways. Can you give the causes? Can you give the how you prevent it? Can you give the effect on performance? Smoking, I'll look at you a little bit with tomorrow. Make notes on this. Do it well, please.